Okay, the drawing needs to be modified slightly. Make sure your phone's put back away now that the 1 minute break is over. There should be arrows here. This was left off the drawing unintentionally. This should be an open circle. This should be an open circle. This should be an arrow. Okay? They give you a picture of f prime, and they ask you to talk about what f is doing. So this is a straight Danica's chart problem. You're looking at f prime, you're trying to figure out for what x values would f be decreasing. Just see if you can do it. So you give me your vote. Answer it would be A, B, C, D, or E, and it's not good to guess in this class. It tends to make you worse. If you really don't know, just tell me you don't know. But you're looking at the graph of f prime. You're trying to say, I don't see the graph of f, but if I understand f prime, Danica's chart reminds me of how f must look. So show me your answer. This is a perfect example of what you're going to encounter on 26th September. So show me your vote. If you're doing this, give yourself 2 points. I'm looking to see where f is decreasing. That's going to correspond to everywhere that f prime has negative y coordinates. So right here, we'll go to ht. Y coordinate here of f prime ht, positive or negative? Negative. Keep talking. Negative. That one's 0. Skip that for a second. 2 points for ht. So sure enough, from 2 all the way to negative infinity, we have values of f prime that are negative. That means that the graph of f itself that we can't see would have to be going down in that span of x coordinates. Question. You need me to say it. Yeah, Gabe, please.
How is it decreasing when it's going that way?
So, say your question again, but just don't say the word yeah.
When f prime, why is f prime decreasing when the graph is going to the left like that?
I'm going to pay you a ticket for a good question. Hold on a second. So we're looking at which graph, Gabe? Good. And as we read the graph of f prime from left to right, the x coordinates are absolutely increasing. That's true of all graphs we read, so we're not really thinking of that, to be fair. We're just saying, okay, f prime, yeah, left, right, the x's go up. They always do. What we're focused on is they want us to figure out, hey, you don't get to see f. It's not displayed. But if you could see the graph of f, where would the graph of f be going down? Like as you read the graph of f, you'd still be reading left to right, but you'd be looking for f to do this. Okay?
Yeah.
And the chart reminds us of how to figure that out. It says, oh, can't see f. That's okay. I can't see what f looks like. But I can see what f prime looks like. And anywhere that f prime has a negative y coordinate, f prime tells us how f is changing. So if f prime is negative, f has to go down. So now I know that in this span here, from -2 to forever that way, all of these x coordinates will be x coordinates where f has to be going down. Did that help at all? Okay. Anybody else? Okay, cool. Move on. Stop that recording.
So we have a question.
Yeah, please.
Just at the -2, when it looks like it's 0, you just still decrease.
Gotcha. 2 points. Actually, I'll pay a ticket for this one for Tara. She's the one spokesperson gets the ticket. So, let me explain what's happening there. It's not perfectly clear, but it's really not too bad. We talked earlier with Sam, look at me, that when you have a graph that's going down, and you check one y-coordinate, and you check another, and you check another, and you check another. If that graph does this, it looks like the graph is flat in the middle. It really isn't flat. It's just changing so minutely that it appears to be flat. But if you were to examine with a microscope, an imaginary infinitesimal microscope, you would see that every y-coordinate is actually lower than the previous. So it's always going down. However, because they get so close to each other, right in the middle, we say mathematically that the tangent slope of this f right in the middle would be 0. The tangent slope on f that is equal to 0 gets plotted as a y-coordinate on f prime that is equal to 0. So that dot really does have a y-coordinate of f of 0. But it doesn't change the fact that for all of those x's, f is still decreasing. Except for that, well, that one spot, f's still going down because the dot just to this side of it would be higher, and the dot on the other side would be slightly lower. Just mathematically, the slope in the middle is 0. That causes this f prime coordinate to be 0. But f is still decreasing for all of those x's. Is that better?
Yep.
Okay, cool. There you go. 5 each.
Half a ticket. That's what you get for complaining.
Questions? Anybody else? Well, next run. Stop the recording.